Okay, let's just see. Seems like the recording is underway. Okay, so tonight we're going to do a recap of assignment 4. So basically just looking at the mock assignment that was shared, and then on Thursday, again the same time, 5:30, we will have another session. So if you are not on our WhatsApp group yet and want to join the WhatsApp, I will quickly just put the link of the WhatsApp group in the chat. The link is in the chat. So again, I'll share on the group the link to the session on Thursday, and then we will also again have a session on Sunday morning. Okay, so let's get underway. So we're going to look at the mock assignment that was shared. You guys will notice that some of those questions we actually did last week. So we're gonna look at some of those questions again, and then we will also look at more questions during the week in our other sessions as well. Okay, so the first question, and also similar to one of the questions of last time, is we need to look at the information, but more important, what they want us to work out with this first question. So they want us to work out the standard error of the mean. Okay, so even though we working with confidence intervals, hypothesis testing, the work that we did in chapter 6 and 7 is still very much relevant. So chapter 6 and 7 is nearly it is very important for chapter 8 and 9. So we start off with a question on, and that is way too small, so let me just get okay. So standard error of mean. So if it is that we know what the standard deviation is, or if we know what the population standard deviation is, this is the formula. If it is a sample standard deviation, we will use the sample formula for the standard error. So let's look at the information that they give us. Population standard deviation is 35. The sample size is 100. So this one is nice that I don't need to get my calculator. So 35 divided by 10 will give us 3.5. Okay, and that is option 3. So very, very important just again to check for this one, even though we are doing confidence intervals, we're doing hypothesis testing. Very important again to nearly look at the standard error of the mean, and just why it is important. So when we get to the question around the confidence interval, remember this component is always the standard error of the mean. So that's just why they also in the assignment uh, added this component back in, because even though it was dealt with in chapter 7, still important for confidence intervals. Okay, so when we look at this one, standard error, use the standard error formula, and then we will work it out by looking at the standard deviation divided by the square root of the sample size. Okay, so that was question 1 of the mock assignment. Question 2 now goes into much more detail. So question 2, and let's just make this bigger. So question 2 now goes into asking us to work out what the confidence intervals are from a question. So let's look at this question. Let's first see if we working with a Z, if we're working with a T. So let's a household survey based on a sample of 50 households. So we've got our N, in a small rural village, found that the average household income to be 3,000. So average household income is 3,000. So that is our X, with a standard deviation of 900. Construct the 95% confidence interval estimate for the population mean household income and choose the correct answer from the list below. Okay, so first thing that we going to check is it population standard deviation or is it sample standard deviation? Okay, so let's just first see. They tell us that found the average household income to be 300 with a standard deviation. Okay, so we can't see, or they didn't specify that we're working here with a population. So for me, we are working with the sample because they did not tell us what the population standard deviation is. They told us in this village what some of the average household is of those 50 households. So we don't know what the population standard deviation is. Yes. So default always to sample if it is not given. Okay, so they need to tell you that we're working with a population. Okay, so because it's sample, we will need to work out a T. So let's first write down the formula, and then so still, even though it is a S or sample standard deviation, that is still the sample error. So let's quickly see. We will need to work out a T. So for the T, we need to get degrees of freedom, and we need to get alpha divided by 2. Okay, the degrees of freedom is n minus 1. So that's 50 minus 1. The alpha is basically what's left of, if we take off the 95 from 100, so the alpha is 5%. So 5% divided by 2. So we will sit with degrees of freedom of 49. And let me just make sure 5% divided by 2 is 0.025. Okay, so time to go to the T table. So let me just open up, see if I have it, just open up the T table that we can go to that again. So we've been using this table for some time now, the last couple of sessions. So T table, let's see, 49, 0.025. 49, okay, 49, so there. Wait, let me just see if I can draw. 49 with 0.025, 0.025, 49, wait, 2,0096. Okay, so 2,0096. If we used the Z, we would have used 1,96. So the two numbers are not too far away from one another. So you can see that there's some of these numbers that are really close. So those two very close, those two very close. That, or sorry, that one is a bit further out, but those two also very close. So by using 1,96 and by using 2,0096, you can probably get close to one or one of the other ones. So just be very careful again, and we can work out what it is if we use 1,96 just to make sure if there was an answer or not. Okay, so we've got the x is 3,000 plus minus the t of 2,0096 times 900, because that was the standard deviation, divided by the sample of 50. Let's check 900 divided by sample of 50. Sure, I get 1,127,2792. So if we multiply that by 2.0096, I get that we say 300 plus minus 25578. Okay, so then it is that plus 3,000. So my top one is 325,78. So there's a bit of a difference, not too much. And if we set negative, we get 2744. Okay. So working with option one. I just want to check if it was 1,96. So if you said 1,96 instead of a 0,2296, let's just see if there was an answer as well. Okay, then we would have gotten to option C. Okay, so if you used the 1,96, we would have had option C as your answer. Okay, so important in this one, first thing you need to identify if you're working with a standard deviation where you know what the population standard deviation is, or if you don't know, nowhere in this did they tell us we know what the population standard deviation is. Okay, so we don't know what the population standard deviation is. So we assume that we're working with a sample standard deviation. Because it's a sample standard deviation, we work with a t. Then important, for the t, the degrees of freedom is 50 minus 1, which is 49. We work with the alpha divided by 2. So we get the alpha by saying 100 minus 95. So that's the 5%. And then just again, we have degrees of freedom of 49. We have our limit. So then we go to the t table. We go to the t table where degrees of freedom was 49, the 0,025, which is 2,0096. So for the t value, we will use that. Okay. So, and yes, unfortunately, there is an option if you have gone with the Z. Okay, so then you will get option C. Okay, this one we did last time, and so let me quickly. What I did is so let's just see if everything was covered in a question. So still 27 degrees of freedom. So the only difference nearly is that things have been swapped around. So there's the t value associated with lower tail of 0,025. There it is in that one. The t value associated with lower probability. There is exactly the same question. Then the 95%, there is the same that we did. Then the 80% the same, and the 90% the same. So exactly the same question as what we worked on last time. So what I thought is, let's just, for one of them, just show you again how to look at where we need to get the t value, and we will look at one where we need to get to the area, so that at least we just go through the process again. So they tell us degrees of freedom is 27. Okay, so here we sit with everything, all the degrees of freedoms that are 27. So let's just see if we can make it a bit bigger. One smaller, that we can also just look at that component. Okay, so let's first see if we need to work out a t-value. They say, what is the t-value associated with a lower tail probability of 0,025? Okay, so lower tail probability of 0,025. So the answer would be 2.0 or 2.0518. But remember, because it's sitting on the lower side, as in your Z, here it's the minus t, where that is positive t. So just remember, as with your Z, you can look at it in the same way. I want to see why I didn't that. Now cancel it totally out. Okay, cool. So for the degrees of freedom, 27, lower t, we get minus 0,2052, which is correct. Okay, then let's look at one where we're working with, let's say, 80% of the area is between two values. Okay, so let's first draw this again. Okay, so here we see it. So let's just remember they tell us that 80% of the values or the probability is between two t values. Okay, so that's 80% is between minus t and a positive t. Okay, so just remember, because there's 80% and this whole area needs to be 100%, what's sitting in this component is 10%, and what's sitting in the other component is 10%. So if I'm looking for this t value, I'm not going to look at the 80% to find the t. I need to see that area, because that is how this works, is I need to find out that whole areas, and that whole area is 90%. So I will need to work with a cumulative of 90%, or then your upper of 10%. So that will give me a value of 1.3137. So on the upper end, I will have a positive 1317 or 3137, and then at the negative will be negative 1.3137. And so if we then check 1.3137 was rounded off, So that is correct. Okay, so that is how, again, just a quick recap. We we did go through everything last time as well. So what I also just added again is all the ones that we did last time, just so that you can see over 80% was for 90. When it was 95%, we needed to add another component. So it was your 95% confidence interval, it was actually 0.975. And for 90, we needed to add 5%. So that would have been your number. So just again, if you look at it, just remember that every time that we look at this picture, it's just like the Z. The alpha only is referring to this top. So when we look at confidence intervals, remember it is on both sides. Okay. So that nearly, it's exactly the same with a Z. So there's the positive Z, this side is a negative Z. So that's why, again, we can say that is exactly the same size as that one. Okay, so that assumption we can do with the T distribution as well. And just again to show you, as T becomes bigger, by the end, you nearly sit where your T value becomes the same size as your Z. Okay, so that might be even a theory question at some point, that your T distribution actually, as your sample becomes bigger, does tend to become a normal distribution. Okay, so we follow the same process with a confidence interval. I think this was around question 4, if I'm not mistaken. So let's just read through it again. Simple random sample of size 19 from a population, normal population, results in a sample mean, sample standard deviation. Okay, so again, we're working with samples. So this one will be exactly the same as the one we did in the previous. We will just need to get a new value for T. So T is n minus 1. So it is 19 minus 1 is 18. And then again, we sit with 95% confidence interval. So that is 100 minus 95 is 5%, divided by 2. So we again sit with degrees of freedom and 0.025. Okay, so let's see T table, degrees of freedom of 18, degrees of freedom of 18, 2, or 0.025, just check 18, 0.025, so 2,1009. 2,1009. The standard deviation. Let's quickly check standard deviation. Sample standard deviation was 50. Sample was 19. And the mean was 200. Okay, so let's see what we get here. 50 divided by square root of 19. I get 4,3589. So if I multiply that, 50 divided by the 4, gives me 11.4709. So if I multiply the 2,1109 times 11,47, we get a plus minus 24,099. Let's quickly check. I want to round it off to 2 decimals. So it will be 24.10. So 200 plus minus 24.20. So the top one is 224.10. Let's quickly check. Okay, so there it is. And then if I say 1 or 200 minus that, I will get 175.90, which is option B. Okay, so again, in this one, first we identify if it is a Z or T. So because sample standard deviation, we basically know that we are working with a T. Then we need to get to the T value that we get from the T table, which is 2,1009, and then we can solve it. I just want to check again. So if you used a Z of 1,96, we would have gotten 22.48. So if you used a Z instead of a T, you would have gotten to option E as your answer. Okay, so again, just be careful and just be on the lookout what you need to which choice you need to make between a Z and a T, because if you make the wrong decision, there is an answer for that wrong decision, unfortunately, as well. So very important. Sample standard deviation showing us that we don't know what the population standard deviation is. So it's unknown. Because it's unknown, we go for a T distribution. Okay, let's look at the next one. And with this one, we see, okay, we're working with proportions. Okay, so what is again important, and I have included it in this pack again, proportion is always Z. Okay, so when we see proportions always Z, So we can go back to this one, proportion. We know that we're working with a Z value. We see 95%, so we can automatically say, because we're working with proportion, we're working with a Z, because it's a 95% confidence interval, it is automatically 1,96. How do we know that? So we can, again, and it is included in this pack again, 1,96 is your two-tail. And that we always use for your confidence interval. The 95 is the one that we can use. 95, 1,96. Okay, so proportion, the formula is a bit different. And again, just I don't always remember the formulas. Remember it's open book, so you are also to be allowed to use your book, your study notes, these notes. So it's just that is the formula, P1 minus P. So let's just quickly get to that one, sorry. Divided by N and square root. So let's quickly see, in a sample of 90 schools, 72 schools reported a decline. The P is equal to 72 over 90. Check what 72 divided by 90 is, 0,8. Okay, so 0,8 plus minus 1,96 times the standard error. So that is 0,8. 1 minus 0,8 is 0,2. And that divided by N, which is 90. So let's just write it down so that if you're doing the calculations later, you have it. So 0.8 times 0.2 divided by 90, and the square root of that. Now let's just see if I want 3 decimals. Let's just do that. Times 1,96. So I get 0.8 plus minus 0,083. So at the top, it will be 0,883. So let's just see, 0,828683. And then at the bottom, it will be 0,717. Which is also there. Okay, so this one, we're working with a proportion. Then for proportion, we look at gonna use a Z. Then we use the confidence interval formula, and we get our answer of option C. Okay. So this one we are going to look at, what I've done is from our last session. So the only thing in this question that changed from our last session is the sample mean. So if you look at it, sample still 36, the sample mean has changed, population standard deviation of 16, where it was population standard deviation of 16. So again, if you look at, it was also bigger. So very much, again, a question that is very similar between an assignment that was done 2-3 years ago versus the mock one. So again, the more we practice these, I think you guys will also see um, a lot of the same questions being used. So again, a tip nearly for your assignments. So you are allowed to do, I think, 2 or 3 attempts. So even if you score good in your first attempt, try another one just to see all the questions, because we have seen that they do use a lot of the questions repeatedly. And so it might just be that some of it is in your exam paper as well. Okay, so first let's check the T-stat. So T-stat is just like we did again in study unit 7, how to work that out. So we look at the X. In this one, the sample mean is 84. The population mean is 80. Standard deviation is 16. And your N is 36. Okay, so 84 minus 80 is 4. And then 16 divided by 6 is 2,667. So 4 divided by 2,667 is equal to 1.5. Okay, so T-stat is 1.5. Okay, so that is what is a bit different from the question that was dealt with previously. There we had that the T-stat was wrong. So here T-stat is correct. So let's then look at, okay, so if we're working with a T-stat of 1.5, oh, let me, that does not look great. So let me just quickly take that away. Let's also move that a bit up. Okay. So let's just look at, if we draw this Z diagram where Z is equal to 1.5, what is our p-value? Okay, so again, remember out of study unit 6 and 7, we don't have a table that directly tell me what that area is when we look at positive. We know what what this area is, but because of the symmetry, I can get that smaller area on the negative table. So with Z is minus 1,5, I can look at what the Z value is. So Z minus 1,5, so 0,0668. So if I look at the p-value, 0,0668. Okay. They say that the p-value is 1 or 0,1336. Okay, wrong. It is 0,0668. If this was H1 is not equal to 80, then it would have been a two-tail, and then that would have been right. Okay, so that 0,1336 is when we have a two-tail, because then we would have said we've got another piece on the left-hand side as well, so then it would have been 0,0668 times 2, and then we would have had B as the correct answer. Okay, so that, yes, okay, and that is why be very careful with this one, because again, what I've now done in this one and in this one and in the other one, they have used a one tail. So just be careful that if you do your assignment, that they don't throw in the two tail, because they have not tested at all in any of the questions nearly around the two tail. So just be careful, because like you said, that p-value times 2 will give you that. So when we have a two tail, it will be that answer. Okay, the other ones, the upper Z tail, yes, because it's bigger than. If it was smaller than, it would have been the lower. So again, because of the bigger than, we're looking at the upper T. So again, that is why that one is also correct, option E. And then just quickly, what we look at the 10% level of significance, the null hypothesis is rejected. So let's just look at this, because they never told us what's the critical value. So we only now worked out what the t-stat is, that is 1.5. At the 10% level of significance, let's look at, sorry, where is that table? Remember now, we're working with a one tail, 10%, 1,28. So there is our 1,28. So if my critical value, so if my t-stat that I've worked out is 1,5, so if a t-stat is bigger than my critical, which is 1, let's just, which is bigger than the 1,28. So if my t-stat is bigger than the critical, H0 is rejected. Okay, so that is important. Okay, so because it lies to the right-hand side, will be rejected. If it was to the other side, it would have been accepted. So let's just, null hypothesis is rejected at the 10% level of significance. The rule is to reject the null hypothesis if the p-value is less than or equal to 0,1. So that is another way to look at it, is your critical value, the t-stat is, or sorry, the t-stat is bigger than your critical value, so we will reject it. The other one is to say, well, look at your p-value, 0,0668, and now there it's just the opposite. It's smaller than 0,1. So because of that, the H0 is rejected. Okay, so you will see, so the T stat bigger, but because it's a bigger T stat, it will mean that your P value becomes smaller. Okay, so that also will always go hand in hand. The bigger the Z value that you work out, the smaller the P value will become. So if we look at a Z of 2,5, let's look at a Z of 2,5. So now you suddenly 0,0062, 0,0062. So as your Z value also increases, your P value will decrease. And that is just because as we move that Z to the right-hand side, your P value will become smaller. So let's just quickly show that. And it's just to nearly, so let's say that is the 0 again. So let's say that is Z1. Okay, let's say that is Z1. Uh, then you can see a big area. So then we get to Z2. So your Z becomes bigger, but then that area that is left becomes smaller. So if we have, and let's just do something like this. So if you then even have a value of Z3, your p-value is even smaller. So the bigger the Z, as your Z increases, it will mean that your p-value will become smaller. Okay, so as Z increases, your p-value becomes smaller. Okay, so you will always, the Z will be linked to the critical value, and your p-value will be linked to that alpha value. So you can again see they link that level of significance, which is alpha, to your p-value, and then the t-stat is linked to your critical value. Okay, so very similar to what was done in a previous assignment. So again, that's why I think it's important, if we can get access to more previous assignments, the better for you guys, then we can cover more of it. So this was just, let me take this one out. Okay, so then there was a question again. Last time we looked at one-sided minus 2,74. So this time around, very similar question. Suppose the calculated t-stat for one-sided lower tail is minus 2,82. So minus 2,82. Suppose further that the population standard deviation is known, so we can work with a z. What is the p-value? So you want to know what is that area. So z equal to minus 2,82 minus 2.8, 2.8, 2.82. So 0,0024. That area is 0,0024, which is option A. Okay, if it was two-sided, then we would have needed to add another area in here of 0,0024. Then it would have just been that multiplied by 2, and then the answer would have been D. So if it was two-sided, then our answer would have been D. This one is one-sided, so that's why the option is option A. Okay, so just again, be careful between the one-sided and two-sided. For all of these questions that we've nearly dealt with the last week or so, it always has been a one-sided. So even the one that I have from the previous, all that they changed was the minus 2,72 was now minus 2,82. Look, even all the answers is nearly the same. 0,0024, then 0,0031, 0,0039. So some of it not, but again, very similar to some of the previous options. So again, what they probably did in these two is that they just sometimes change your value. Yeah, I see. So a lot of the time it is then something different in the exam. So I think it is nearly important that a lot of the time what then happens in the exam also is that they might have it as two-sided, um, or they might have that as a positive. Um, so the things that we haven't really seen being asked, then suddenly it's all positive or it is two-sided or something like that. So yeah, even if it's not in the assignment, it might even be that in the exam, then it goes the other way around. Okay, so I think this one was also very similar to the previous question. So we will cover it quickly again, but look at exactly the same. Sample of 100, sample of 100, population proportion, or sample proportion. Let's just quickly see sample proportion, looking at the test equal and not or smaller than. Where is it? Smaller than. Okay, so again, very similar or exactly the same as the question that we've done last week. So let's just quickly look at it again. So we will need to work out what the Z value is. So Z value, and let's see what's the formula. So that before I now do the wrong formula, because by using it wrong and you've replaced here the population standard or the population proportion with the sample proportion, you will get a different answer, which is one of the other options. So let's see, sample proportion 0.32, population proportion 0.4, divide by population proportion 1 minus population proportion divided by sample, which is n. So the Z value, and I'm just going to check on this one, was minus 1.63. And again, important to look at the normal distribution. Minus 1.63. It says smaller, so we're working with this area, which is smaller, so that is going to be the p-value. Minus 1.63 minus 1.63, 0.0516, 0.0516, which is option A. If it was not equal to, then it was two-tail, then we would have added this component. If it was two-tail, then the option would have been option C. So again, nearly we again not seeing any of it to tell. So again, just worried that they might give something like this in the exam, or even now with your assignment. Okay, and yeah, it was exactly the same one that was in a previous assignment. So this was actually assignment of 2 or 3 years ago. It wasn't a mock assignment, it was the assignment. Okay, so let's look at one more. So we've got one more, and then again, as you will see, I have added some of the theoretical information and all the formulas in as well. So let's look at this one. And the reason why I've included this one, it wasn't in a previous one, and here they specifically looking the whole time at, you're looking at the null hypothesis versus the alternative, and you need to make a decision if you accept it or reject it. So let's read the information and let's see what they say. Various literacy groups recommend a reading speed of 177 words per minute for grade 6 learners. The grade 6 teacher is convinced that the average reading speed for her class is less than the recommended reading speed. In a sample of 35 grade 6 learners, the average reading speed is 168 words per minute, with a standard deviation of 28 words per minute. You are required to test the teacher's hypothesis that at a 1% level of significance, her grade 6 class reading speed is less than the recommended reading speed, and choose the correct statement. Okay, so sample. So let's okay, and let's see if we can the grade 6 teacher is convinced that the average reading speed for her class is less than. Okay, so that already tells us where your mean might be here, bigger or equal to 177. She thinks that it is less than 177. Okay, so that is her belief, less than. So let's work out the Z. So average that she said, or the sample is 168. The population is 177. Grade 5, so that is 2035. So remember standard deviation, even though it's a sample, standard deviation divided by 35, that makes it a bit not nice. Square root of 35, that's not going to be a very nice number to work with. So at the top, it's -9 divided by 28 divided by 35. Sure, please just check if what I'm doing here is correct. Okay, so, and then let's just see if it's a Z test. So you are required to test hypothesis at 1%. Okay. Minus 1,902. 1%. Sheesh. 1% is 99. One tail 2,33. Minus 2,33. Okay, so that falls within. So the critical value is bigger than the T stat. So that means that I will actually accept the null hypothesis. Because it lies within, I will accept, but let's just see what the differences are here. We reject the null hypothesis and conclude that grade 6 average reading speed is less than. We reject the null hypothesis and conclude that grade 6 average reading speed is not significantly different. And so that already we do not reject. Okay. So we do not reject the null hypothesis. So that's correct. And conclude the grade 6 average reading speed is less.
I'm sorry, Jean.
Yes.
Quick question. I don't want to type. Should we not use why are you using the Z?
Oh, sorry.
Did you
Yes,
get what I'm
sorry.
asking, ne? Yeah, we need to
Yes.
go. Yeah, okay, goed. Okay,
Yeah.
dankie.
Yeah, sorry. Thank you very much. We don't know what the standard deviation is. So not going to use the Z, going to use the T. Which will probably, let's quickly check.
I think we need to work out the degrees of freedom as well.
Yes.
Yeah.
So degrees of freedom will be 34 at that 1%. So 1% divided by 2. So 34 and 0,005. Okay, it's also still going to be a very big number. So let's quickly check. Degrees of freedom, 34. 0, what did I say? 0,005. 34, 0,005. Let's just 34. Okay, so your critical value is even bigger than that. Okay, so we still need to, for the T stat, we still use this. Okay, so that's not going to change. We just test against a different critical value, but that's just going to be even higher. So it's actually not going to make a difference in this one, which one we're going to test against. So it will be interesting. I will just check if there's any of hypothesis testing where they actually, where we actually do go into a T, and then that will be quite interesting. I'll check for you guys if I've got any more of this somewhere. Yeah, I'll check for you guys if I have something else on this as well too, because all of this currently was only looking at Z, and they specifically said for all the other ones, population standard deviation is known. So I will just check again if there is anything more on this. Okay, so we do not reject the null hypothesis. So that is true. We do not reject the null hypothesis. But because we do not reject it, we can't conclude that the average reading speed is less. We did not accept the alternative. Okay, so we do not reject the null hypothesis and conclude that grade 6 average reading speed is not significant different from 177. Okay, so we do not reject, so we can't say that it is different from the 177. And that is what option D. So what I would have loved is that they say, rather, let's accept the null hypothesis. So do not reject is the same as accepting the null hypothesis. And by accepting the null hypothesis, we say that no, that the teacher is not right. The class don't show in this that there's a difference between their scores and what is the scores of the population. Okay, so we do not reject the null hypothesis, and thus we can conclude that there is no significant difference. Okay, so that is how we will look at this one. If it was, we rejected the null hypothesis, so if we said, okay, we reject the null hypothesis, we accept the alternative, then the wording would have been, we reject the null hypothesis, and we can conclude that the class reading speed is less than 177. Okay, so that would have been then option 1. So again, just be careful when you guys also, because there is 2 or 3 different assignments again. So it might be that with some of your questions, you might get the opposite. Okay, so hypothesis testing, so confidence interval, so let's quickly look at confidence interval. If your standard deviation is known, you use a Z. When your standard deviation is unknown, you use a T. And then if your confidence interval around the proportion, you will always use a Z. So they can say population proportion, sample proportion, anything, doesn't matter. If it is proportion, you use a Z. Okay, so that is why with a confidence interval, so let's just recap you will always have the Z with a standard error, or if it is unknown, it is the T with a standard error. Okay, that is when we have the mean with confidence interval. So it's all the Z with a standard error or the T with a standard error, and the proportion always the Z. And confidence interval is a bit different. So when you look at confidence interval, so, and that's why we've worked out the Z. If you work out the Z and you work out the T, see, it's exactly the same method for the hypothesis testing. So your mean, your population mean, standard error, one is just population, standard error of your sample in your unknown. So doesn't matter if we, in hypothesis testing, work out the Z or the T, we always call it the T-stat. Your Z and your T, you actually work out exactly the same. But then when you test it against your critical value, that is where it might differ. Okay, so if you test it against your critical value, if it is a Z value, we use the Z table. And now, as in the one we just did, because it is a T value, we use the T table. Okay, and the reason why we needed to use the T is, let's read through this. A teacher convinced the average reading speed of a class. In that sample, the average reading speed and the standard deviation. Okay, so population standard deviation is unknown in this one. Because it's unknown, we will use a T, so that we could have just, and let's quickly change it, even though it is exactly the same formula. We got the T as minus 1,902. From the degrees of freedom and the alpha, we got that, what did we say? The Z was 2,72. So let's just do that. That was actually minus 2,72. And so when you use degrees of freedom is when your standard deviation is unknown. So when your population standard deviation is unknown, we use a T. Okay. And the way that we work out the T for this T stat is exactly the same how we would work out the Z. Okay, so this one is very important nearly to, so if your population standard deviation is known, if it is unknown, the way that we work out that T stat is exactly the same. Okay. The only thing that changes with hypothesis testing is then what we test it against. So do we test it against using a t-value table, or do we test it against using the z table? Okay, so that is nearly the more important thing, is what do we test it against. In both of these ones, that critical value was big. Okay, so because of 1%, because of that 1%, it really becomes that we're working with big numbers. If it was a 90%, then it does become probably smaller, and then one makes other decisions around the null hypothesis. Okay. So that is it for tonight. And I think, again, very, very easily, one can make this mistake. Luckily, in the end, it did not matter for this question if we tested it Z against the T, but it might, if we were at the 5%, it might just be a different answer that we get to. So very important nearly, and I made the mistake in this one, is that here we are working with, actually, your population standard deviation is unknown. Because it's unknown, we work with a T. We work out the T exactly like we will with a Z value, but what we test it against is against a T value that is degrees of freedom and not from a Z value table. Okay. Let me stop the recording. I will make the recording available. I will put it on the MyUNISA website. I will also put it on